Welcome to IEEE's milling tutorial sponsored by Texas Tech University's Electrical and Computer Engineering Department as well as the IEEE local chapter. This tutorial will cover the entire milling process from start to finish and should answer any questions you may have about the milling process. So what is milling? Milling is essentially printing your circuit onto a piece of copper. It allows you to make much more complicated circuits, and it also allows for much cleaner circuit designs. It can also be much more efficient than prototyping on protoboard or any other type of board. This also allows you to check your design before having it professionally made or greenboarded. There are a couple materials that are required in order to mill. The first of which is the copper substrate. This copper substrate is a board which can be typically found in the stockroom. It will have copper on both sides of the board and a piece of fiberglass will be sandwiched in between. These two layers of copper are what form our traces after being put through the milling machine. The next thing that's required to mill are milling bits. These bits are typically provided by the stockroom, but the selection is not very good. I would recommend looking for bits online from several retailers and holding on to them. Having your own bits makes it much easier for you to mill, and it makes it much more convenient. There are several types of milling bits, the first of which are drill bits. These bits are required to drill holes for through-hole parts, and they're also used to drill mounting holes for several other parts such as RJ45 connectors or any type of BNC connectors. These can typically be found at Harbor Freight Tools. Useful sizes for these bits typically range from 20 mils to 50 mils or 0.020 inches to 0.050 inches. The next type of bit is called an end mill. Precision end mills are typically used to cut out the copper so that traces are formed on that big copper conductor. These bits are typically sold in degrees, which will mean the steepness of the bit. 60-degree end mills will usually do a fairly decent job. They will most likely do anything down to about 10 or 12 mils. Now, if you require something much smaller, such as you're setting down an MSP 430 onto a milled circuit board, you may require a 45-degree end mill. These bits can cut out traces up to about 6 mils when used properly. The final type of bit is called a cutout bit. Cutout bits are not required in order to finish milling your board, but definitely help. These cutout bits are used to, as the name implies, cut out your board once it's done being milled. Typical sizes for these bits are 50 to 65 mils or 0.050 inches to 0.065 inches. The final material that's required in order to mill is tape. Duct tape is typically used, but you can really use any other type of tape. The reason for using tape is so that you can hold down your copper substrate onto the machine temporarily, but still be able to remove it when you flip the board or once you're done milling. So let's get started. The first thing we have to do is double click on IsoPro, as this will be the program that we'll be using for the rest of the tutorial. Once the program is open, the first thing we have to do is initialize the mill. What initializing does is it'll reset the limits on the table and it'll let the machine know where the maximum and minimums are. Once the machine is done initializing, it should stop around this point. The next thing we have to do is move the machine head, which is shown here, out of the way. We do this so that we can set down material, or our piece of copper, and so that we can tape it down and not have to move around the machine or anything like that. We do this by selecting Mill and Material Change. The next step we have to do is place our copper board. I've already went ahead and drilled a hole for the alignment screw, but all you have to do is drill a hole and align it to the edge of the board, as you can see there. After that, all you have to do is tape it down to the table and you should be ready to go. Be sure that the front of the board is flush with the edge of the table. If it is not flush, when we flip the board, it won't line up and we'll have a lot of problems trying to solder our finished boards. The next thing we have to do is import our files. So we go to File, Import, and Auto Detect Files. We select our files, and we select 4, 4, and inches. What this tells the program is it lets it know how many decimals to take into account. The next step is to isolate the layers. What we have to do is we have to tell the machine what our traces are so that it knows what to separate from the big pieces of copper. So we click on the Isolate tool and it'll bring up this window. We want to isolate our top and bottom layers. We hold Control to select both of them. And I'm going to go ahead and type in 8 mils as the isolation. What this will tell the machine is it should form layers that'll tell the machine head where it will cut out. As you can see here, once I zoom in again, it didn't catch all of my traces. So the way to fix that is I have to delete these layers, as you can see here, and then I have to go in and run isolation again using a smaller width. The smaller width you use, the finer bit you're going to have to use. So be careful. As you can see here, once it comes up, the layers should be correctly isolated, and there should be yellow lines in between all of my layers. This is correct. The next thing we have to do is we have to adjust the layers. What this layer tool does is it'll let us edit whether layers are isolation, not isolation, or flipped, etc. I'm setting the cutout layer, which is the layer which will cut out this green square, as isolation and as mirrored, because whenever we do the bottom side of the board, we'll have to mirror everything that we see. I also set the bottom isolation layer as mirrored. One of the final steps that we have to do before we run any layers is we have to make sure that your circuit board will fit on the piece of copper. So what I'm doing here is I'm going right-clicking and going to Machine and Jump to Cursor. What this will do is it'll make the machine head move to where that cursor is. Now what I have to do is I have to make sure and test that the board will completely fit on the copper. It won't go off onto an edge. It won't hit that little guide pin. And I'm a little bit off here, so what I'm doing is I'm selecting everything, all of my layers, and I'm moving it over. Once again, I do have to test to make sure that everything fits, so I just go to Machine, Jump to Cursor, and the machine head should move to where I just right-clicked. Now, the thing is that you won't always get it on your first try. You have to keep moving around a little bit to make sure that you get everything aligned exactly where you need it to be. You also want to make sure that you test both edges, or two edges of the board, because if you don't test two edges, you might hit some duct tape while you're milling. You might do something that may damage the machine. Alright, so now we're ready to go ahead and run our layer. What I do is I hide the layers which I don't need to look at. So the component layers, the layers that you brought in with your Gerber files, we really don't need to see anymore. We only care about the isolation layers, the layers where the tool's actually going to go through and cut out copper. So what I'm doing is I'm just hiding them to also make it easier for me to see whenever see how the machine is doing, see how far it is from being done. In order to run the layer, what I'm going to go ahead and do is right click on the drill layer. I'm sorry. You right click on that and you select run layer, and sometimes you'll get an error like this. Certain parts in the SparkFun library, if you're using EagleCAD, might generate an error like this, so it's always good to go back and check. What I'm going to do here is I'm going to get the magnification tool, and I'm just going to look at a portion of the circuit just to make sure. You want to make sure that all the holes are centered. You want to make sure that everything looks like it should be where it should be. You don't want any random holes anywhere else. You don't want anything to be out of place, because once you start milling, it's going to be very difficult to align everything again. So it looks like this is all correct. So what I'm going to go ahead and do is once again right click, run layer, and I'm going to say yes to this error. And now what I need to do is I need to insert a bit into the machine. You'll see that the machine head moves a little bit. You also notice this window pops up. You can see that it's asking for a 23.6 mil tool, and it wants a drill bit, as you can also see. Now you'll notice that it says 60 inches per minute, and that's grayed out, and RPMs are 60,000. You always want to leave the RPMs at 60,000, and 60 inches per minute is acceptable for drilling, but not for other processes. So once you click run layer, you'll see the machine do something like this. The machine is actually waiting for you to insert a bit. If you notice on the screen, a window pops up asking for a certain size bit. Now, you may not have the correct size bit or the exact size, but usually going 1 mil over or 1 mil under is alright. All you have to do is insert the bit and tighten it, but you don't want to tighten it too much. If you do tighten it too much, you risk having to use a lot of force to take off the bit and possibly dropping the bit. If you drop a bit, it will most likely shatter once it hits the floor. So what I'm doing here is I'm manually moving the machine and pushing it up or down so that the bit just manages to penetrate the copper. In order to manually move the machine, you have to click the jog button, and you'll see that there's 4 arrows that say X positive, negative, Y positive, and Y negative. Now you can use the arrows on the keyboard to move the head forward or reverse, you know, in the X-axis or the Y-axis, and this should allow you to adjust the position so that you can get closer to the edge of the board and be able to compare and do things like that. You want it to go through the copper and through the fiberglass, but you just want it to go through. You don't want to cut very much into that sacrificial layer, that silver plate that's always on the machine. And also, if you cut very deeply, you can also go into the aluminum plate, and that will automatically shatter any bits that go into it. So as you can see here, all I'm doing is I'm adjusting with that little wheel. Pushing the wheel over to the positive side pushes the bit down, whereas pushing it to the negative side pushes the bit up. You can see here that I have to test, and I have to really adjust the edge a little bit to make sure that everything is just where it needs to be.